Welcome to the first of a series of video presentations detailing progress of the WD&HO Wheels Australia Limited DIET project. This presentation will cover the initial purchase through to site works up to and including the 1st of August 1990. WD&HO Wheels Australia Limited has purchased in July 1989 from BAT Germany a dry ice expanded tobacco or DIET plant. The DIET plant will ultimately replace Wills' existing G13 plant, which is located at its manufacturing facility in Pagewood. The DIET plant was originally in operation at the West Berlin works of BAT-CF, an associate company of Wills. Due to changed market conditions, the Berlin DIET plant, which was commissioned in 1983, became redundant and consequently became available for purchase. Several representatives from Wills were able to visit the DIET plant in Berlin during its final week of operation. As a result of the visit, operating parameters and other such data was recorded and will prove invaluable during the commissioning phase of the project. The DIET process involves impregnating cut and conditioned tobacco with liquid carbon dioxide. There are two impregnators running 180 degrees out of phase. Each impregnator is filled with a charge of tobacco every 15 minutes. The impregnators are filled with liquid carbon dioxide and have a nominated impregnation period. The tobacco is frozen by draining excess carbon dioxide and releasing the pressure. Tobacco laden with dry ice at -80 degrees Celsius is discharged from the impregnators through clump breakers called openers into a vibrating silo called the vibro bin. The frozen tobacco is discharged from the vibro bin onto a weigh conveyor and then through a rotary valve into the sublimation loop. The tobacco, impregnated with solid carbon dioxide, contacts a high humidity gas stream which causes carbon dioxide to sublime rapidly and expand tobacco by more than 100%. Tobacco exits the sublimator loop hot and dry and is reordered by addition of moisture to the desired product moisture level prior to storage for subsequent cigarette manufacture. Dismantling of the DIET plant in Berlin began shortly after its closure in July 1989. It continued until dismantling was completed in November of the same year. The plant was dispatched to the port of Hamburg, where it was loaded onto a ship bound for Sydney. A number of potential sites for locating the DIET plant were considered. Of the Pagewood alternatives, however, it was decided that the location in the northern end of Bond Store No. 2 provided the best situation with minimum building costs, convenient access and minimum disruption to other factory operations. A Wills Project Operational Management Plan was established on the 29th of November 1989, based on a steering committee, an executive project management group, and a technical and administrative resources group. It was resolved that in the interests of the project that grouping of individual disciplines into discrete tender packages would be advantageous. In January 1990, a mechanical project team consisting of Wills staff and Kinsley and Associate staff was convened to jointly produce the necessary mechanical design. An electrical project team of Wills staff also commenced design work on various aspects of the controls and electrical installation. Upon arrival of the equipment from Berlin, all the electrical plant was unpacked and placed under cover. The mechanical plant and equipment was also uncrated. In April 1990, site establishment took place. This involved erection of perimeter fencing with relevant warning and safety signs placed around the construction site, plus the establishment of site offices for the project managers and Wills site project staff. Also, amenities such as toilets, showers, and covered walkway were erected. Following a favourable review of Will's submission regarding odour control, Botany Council on the 5th of June 1990 granted approval of the building application for the diet plant. The approval of the building application fixed the starting date for site works. The floor layout was surveyed and cutting of the concrete was completed to allow for boring of the piers, which commenced on the 11th of June 1990. A total of 25 piers were bored, which took approximately 1 week to complete. All piers were bored to a depth of 6 metres. 3 of the piers had a diameter of 600 millimetres and the remaining 22 had a diameter of 450 millimetres. The piers will be used to support structural steelwork as well as some of the heavier pressure vessels and the compressor. Ongoing civil works continued through June and into July. This involved removal of parts of the existing concrete floor, both inside and outside the building, which was required to facilitate foundation work. Also, several services were required to be redirected. This included a stormwater drain and a fire hydrant. Following removal of selected sections of the existing concrete floor, preparation of foundations for the gas tank, the process tank, the LP receiver, and the compressor commenced. Following discussions with inspectors from the Work Cover Authority, 6 major pressure vessels were removed on the 3rd and 4th of July to the contractor's premises for modifications and pressure testing. The vessels included the low pressure receiver, the gas tank, the process tank, the Linde liquefaction unit, and the 2 impregnators. Testing commenced on the 9th of July and the vessels had been scheduled to be returned to site to suit the erection program of the structural steelwork. In the first week of July, initial quantities of reinforcing steel were delivered to site. Consequently, placement of reinforcing steel and formwork for the foundations of the LP receiver and the process tank commenced. Concrete pouring of these foundations took place shortly afterwards. Sheet piling of the area around the sublimator pit was required. The sublimator pit floor was designed to be 2 metres below the ground floor level. This is to allow part of the sublimator ducting to lie in the pit such that the overall height of the plant would not exceed the roof line. In excess of 100 cubic metres of sand were removed from the pit area to allow for access and formation of the floor and the walls. Placement of reinforcing steelwork was completed in the middle of July. Concrete was poured shortly afterwards. Pouring and finishing of the pit floor was completed in one day. Erection of formwork for the pit walls and placement of reinforcing steel was completed 4 days afterwards. The concrete for the walls was poured and finished on the 1st of August. Coinciding with the early stages of construction, several tobacco trials were conducted using Australian blended leaf at the Malaysian Tobacco Company's factory in Kuala Lumpur. The trials involved using MTC's diet plant with differing tobacco blends and varying moisture contents. This was to determine effects primarily on flavour and process flow. That concludes the first diet update video. Thank you for your attention. Welcome to the second Diet Project video update. This presentation will show the progress of site work detailing events between the 1st of August 1990 and the 28th of November 1990. During August, major civil work continued. The sublimator pit was completed and work on extensive drainage commenced in order to satisfy regulations set down by the Trade Waste Department and the Metropolitan Water, Sewerage and Drainage Board. According to regulations, all the drainage lines were required to be suspended from the top slab on a separate strip footing. Additionally, it was decided that an existing trade waste pit located outside the diet plant would be connected to the new drainage system. A new trade waste sump, 3.5 metres in depth, was installed to cope with the drainage and will be connected via a sump pump to the existing building trade waste system. Reinstatement of removed sections of the old floor was completed in sections to suit the construction program. 7 new drainage points consisting of stainless steel traps and baskets were installed throughout the plant. Pile caps were completed towards the end of August to meet structural steel erection, commencing in the first week of September. The sublimator foundation was also completed at the end of August. This foundation has been designed to support the load of the incinerator, 2 heat exchangers, the stack, and the supporting steel structure. The initial deliveries of structural steel reached the site in early September. The first structural steel to be stood inside the diet plant happened on the 6th of September. The structure that was stood up forms part of a larger work platform area at 5.5 metres above the ground floor. On the 11th of September, the first of 3 sections of floor slab were poured. This new floor slab added approximately 125 millimetres of reinforced concrete to the top of the floor. Several sections of the floor were graded to allow for gravity drainage into the trade waste system. The graded areas were situated in the vicinity of expected washdown areas such as the reordering drum and the conditioning drum. Due to the increased floor height inside the building, An existing section of concrete outside the building had to be removed to make way for the new driveway. In the middle of September, the first of the electrical site contracts commenced. With the construction of the main distribution board completed, a contract was let for the installation of the main distribution board, the high voltage cabling, and the substations. By the third week of September, the middle section of the new floor and the driveway had been poured. The final section of floor was poured on the 21st of September, covering the area which would become the tobacco infeed processing section. On the 25th of September, the largest of the pressure vessels returned from being tested and repaired. Although not the heaviest of the pressure vessels, the low pressure receiver has a mass of 10.5 tonnes and consequently was considered during the planning phase of the installation that the low pressure receiver would be the most difficult lift and require the most consideration. Several restrictions were placed on the installation contractors, some of them including the restriction on lifting the tank through the roof, a restriction on head height inside the building due to the roof trusses, and ongoing civil works around the compressor foundation. It was eventually decided that 3 cranes would be used for the operation, one on either side of the tank, approximately 1/3 of the way from the top, and one on the tail. As it turned out, the entire operation was completed within 2.5 hours. The storage tank, which is the heaviest of all pressure vessels, was taken off-site the same day. Unladen, the tank weighs 15.5 tonnes. Fully laden with liquid carbon dioxide, the tank is expected to weigh 70 tonnes. The tank was removed to be tested and repaired. In the first week of October, many tonnes of steelwork were erected around the 5.5 metre level in the main process area and the CO2 area around the low pressure receiver. Structural steelwork for the firewalls separating Bond Store 2 from the Dyke plant was also erected. Its construction is similar to existing partitions in the Bond Store. Checker plate floor for the 5.5 metre level was also laid in some parts and welded to the structure. By the 12th of October, the first skin of the firewall was approximately 70% complete. The firewall has a multi-layered construction and separates Bond Store 2 from the rest of the plant. The compressor foundation was being prepared for pouring during the middle of October. Its construction includes vibration mounts mounted under 70 tonnes of concrete supported by 6 piers 6 metres in the ground. The incinerator, which provides heat for the process air as well as incineration of odour gases, was also delivered. By the 12th of October, the majority of the first electrical site contract was 90% complete. The remaining portion of the contract revolving around the installation of the substations. The gas tank was another pressure vessel that was delivered on site in the early week of October. It was installed on the 5.5 metre level and is used for both purging and charge. In the early weeks of November, the two impregnators were returned to Pagewood after being tested and repaired. On the 20th of November, both impregnators were lifted into their final position, an operation which required structural steelwork to be installed simultaneously and the use of 3 cranes. The roof truss structure in 3 bays was modified to a portal design to facilitate installation of equipment and to give the required head height at the 9 metre level. By the 28th of November, the majority of structural steel and platform area at the 9 metre level and the 5.5 metre level was installed. The high-level catwalk in the roof structure was also installed. Other major items that have been installed include the vibro bin, the 2 opener enclosures, and the tangential separator. That concludes the second DIET project video update. Thank you for your attention. This video presentation is the third in the series of DIET installation updates. The presentation will detail the major items of plant installed during December 1990 and January 1991. Dust collection plant was delivered and installed. This plant includes dust filters and fans which will be used for pneumatic conveying and classifying of tobacco. The installation of sublimated ductwork was ongoing. This included alignment of pre-installed ductwork in the pit and installation of the process air ductwork. The main process air circulation fan was located in its final position and secured. The incinerator was positioned and bricking of the refractory was completed in late December. During December, the sublimator structure was erected. This structure supports the process air heat exchanger, the air preheater, and the stack, as well as some process air ductwork. The control room supporting steelwork and concrete floor were installed in late December. Currently, the floor is being prepared for wall, ceiling, and elevated floor fit-out. The tobacco in-feed plant is currently being installed. Installation is due to be completed by early February. This plant includes the installation of 2 cutters, a conditioning drum, metal detection and reject facilities, surge bin, and a charge conveyor. This equipment was tested with product and the tests were witnessed by Wills representatives before the equipment was brought to site. The CO2 piping installation is ongoing. The significant items of installation since the last update include pipework around the compressor, circulation pumps, and piping around the process tank and long-run piping. The CO2 room, which houses the noisiest items of plant, namely the low-pressure receiver and the compressor, was enclosed using sandwich panel walls and ceilings. This enclosure effectively attenuates the emitted noises to an acceptable level. This presentation has ended. Thank you for your attention. This video presentation is the fourth in a series of presentations that details the main items of site progress in the diet plant up to the end of April 1991. This presentation was filmed and edited on the 24th of April 1991. In March, the roof-mounted silencers for CO2 venting and blow-off were installed. The operation involved lifting the silencers into position and penetrating the roof with the support brackets, which were secured to the internal superstructure. The sublimator process loop ductwork has been assembled. Currently, it is in the process of being insulated. The process air heat exchanger is also installed and insulated. The control room walls, ceiling, glass window panels, doors and computer floor have been erected. The air conditioning system has been commissioned. The control room gives the operator a panoramic view of the plant, including the main process area, the tobacco infeed and outfeed plants, and from the side window, the sublimator area. Electrical power, control and instrument cabling are currently being installed at the moment in the tobacco infeed and outfeed plants and the CO2 equipment. The three motor control cabinets have been positioned and the internal wiring has been checked. House lighting in the plant is operational in the high bay area and the CO2 room. The cooling tower, supplied by Sulzer for cooling the compressor, and the associated pumps and piping have been installed. Several hundred metres of ducting for pneumatic conveying of tobacco, the return air, dust control and odour control has been installed. The pneumatic conveying system is used to transport tobacco from primary to the diet plant for the fines bypass and for final product classifying. The ducting connects from these inlets to the dust collection plant located under the control room. Odour control ducting feeds either to the incinerator or to the carbon bed odour plant. All the stainless steel high pressure pipe used for the carbon dioxide process has been installed. As a part of the installation process, all of the welds on the high pressure pipe was X-rayed, which included the pipework supplied from Berlin. All the defects that were found were rectified. The pipework has been flushed to remove slag, dust and dags and will be dried with nitrogen and then insulated. The tobacco outfeed equipment has been installed. This equipment includes the reordering drum, which adds moisture to the tobacco, a moisture meter and reject station, the final product classifier and tangential separator, and the final product conveyors. The tobacco outfeed plant receives hot, dry, expanded tobacco from the sublimator. Its purpose is to cool the tobacco, add moisture, test for correct moisture content and reject if necessary, remove heavy particles from the tobacco and deliver the final product to the storage area located in the primary plant. This presentation has shown the status of site work in the diet plant up to the 24th of April 1991. Thank you for your attention.